To the untrained eye, this may seem like an ordinary living room, and it is. So what I have here is my latest wire harness for the Lexus GS450H based EV conversions. I am pretty proud of it and would like to take this opportunity to bring you along while I bench test it. But first, a disclaimer. By no means are any of these ideas my own. The majority of them are borrowed from other folks on Open Inverter, and the minority are stolen. Whenever possible, if my memory serves me right, I will gladly give credit to those responsible, as we encourage the sharing of ideas and resources in the EV community. I believe in separation of church and state, and I design my harnesses to be that way, with a focus on intuitiveness and easeability. So we have the low voltage harness fuse relay box, we have the high voltage contactor relay box, and we have what I call the inline or standalone fuse relay single purpose high current harness, most often serving pumps such as the oil pump or the coolant pump. I believe in completely isolated standalone EV components electronics, such as a separate low voltage current fuse relay box for two reasons. Your old classic OEM fuse block may be dirty, corroded, and or have some cracked or otherwise bad wires. Or you will end up with a much bigger haystack to look for problems in. So why mix the two? So let me tell you about what I have here. And the best way to do that is to separate what is in front of you into four separate sections. So let me tell you what those are. So obviously we have the VCU, the vehicle control unit. The circuit board here does not come with the kit in this particular instance, and this is for one of my customers. He purchased the card and he had it drop shipped to me. I then soldered on this header and I put it in the case for him. This being one of the four components. The other one, and this is what I'm quite proud of, is this 3D printed, what I call inverter high voltage safety kit. By no means is this my design or am I taking credit for it. I believe a gentleman that goes by James on Open Inverter designed this and shared with the community, and I think this is fantastic. I did some horse trading with Arthur K of the Jaguar XJR fame to have him print me about half a dozen of these, and now I can include them in my kit. So thank you, Arthur. I add to this kit some standoffs, hardware, and these lugs for your battery cables. So when we move on to the garage and later on in this video, I'll show you how I built this out. So this is another portion of this kit here. Then we have what I would call the main harness right here. And the fourth component is one of the examples of that standalone harness. This is a harness just for the transmission oil pump, as we call it. This connects to its controller. So I sell this separately, or I include it with the kits. I'll show you how this hooks up later in the video. But for the most part, we'll go over this, then how to hook up the harness. And when you purchase a harness from me that comes with a VCU, or if you want it pinned like this one, and I say sell harnesses at different price points just to accommodate what everybody needs. If it's pinned, then most likely it will be tested. If it's not pinned, all the wires will be labeled to where they go on this connector to the Zombie, but I don't test those harnesses, okay? The best I could do is test them for continuity, but that doesn't make much sense, as then I don't guarantee they'll be pinned correctly once you get it. And so I can't test those for functionality, but you get the idea. Anyway, let's move on to the garage and see if it will spin. So let's say you bought the inverter high voltage safety kit, whether you bought it by itself or it came with a harness. Now what? Well, first let's see what comes in the box. And inside this box, we have this 3D printed housing, and we have this PG19 cable glands, okay? Then I provide you with a positive and negative aluminum standoffs. You'll see later why we need these. longer 50 millimeter M6 bolts, some cable lugs, and some, this is marine grade shrink wrap. It's thicker than the junk you get regularly on Amazon or at Harbor Freight. So it's thicker, and it actually has adhesive on the inside. So I really like this stuff. That's what these are covered with. Okay, I did that for you. Okay, so get this out of the way. All right, so here I have a Camry inverter. We'll just pretend this is a Lexus inverter. As far as this part is concerned, they're pretty much identical. So let's review how this inverter gets its power in its OEM configuration. And if this is the front of it, this is where the motor cables come in. On one side, you'll have the low voltage logical connections, the controls, if you will, the intelligence. And then you have the business end on this side. And in the original vehicle, the batteries connect to this appendage right here. The battery connects here. Let me get the cable. I got the OEM cable from a Lexus just because I'm an OEM harness junkie. So that would plug in here, but we don't do that. And the reason we don't do it is because in the Lexus or in the Camry, it runs on, let's say, 300 volts. We'll just call it that. It's like 280 or 88. So we can't plug it in there because we're going to be running our conversions at higher voltage, 400 volts or so. So I'm going to put this away. This was just for demonstration purposes. And just for completeness, the other connector here, the smaller one, that is for the air conditioning. So it's high voltage direct current air conditioning. And I also have this harness, again, just for completeness demonstration purposes. So this just goes back on the wall of shame. All right, so where does that leave us? Well, we need to remove this metal plate here and expose what is called the main bus, which is like the main skeleton of this box or the infrastructure voltage pathways. And we're going to tap into those, to that bus with our, battery cables. So first thing we're going to do is remove this plate. So throughout the series, I'm going to offer you some top tips. One thing that I've learned is, although you can do it with a socket and your socket driver here, there is a better way because this socket can fall off, right? So a while ago, I had a great boss at work, and her mantra was, you can do whatever you need to do, just make sure the results are always same or better. So we have a better way of doing it, and that is just a socket driver that does not disconnect, right? So I think that makes sense. We can take this a step further and wrap some more electrical tape around there, or literally take this marine grade heat shrink, and I've done that before. You slip it on there so it's fully covered, then you apply heat to it, and obviously it shrinks it and gives you a little coating. You can buy high voltage tools if you like, but I'm a big proponent, believer in, poor man's solutions. So we are going to be dealing with obviously high voltage components, but some of the dangers are minimized when there's no battery pack connected. However, this inverter on the bottom here, think of this like a 3-layer cake. So the bottom layer is a back big ass capacitor, right? So that could hold some serious energy. So when we get to dealing with it, once this is removed, exposed, we'll take a multimeter and see if there's any juice left in there. Because if it's still charged, it's very unlikely if you buy an inverter at a junkyard that the capacitor is still holding a charge. because this box has a bleed down resistor, so it drains the energy, turns it into heat and dissipates it. And it does that within seconds, if not minutes. So of course it can do it in days, weeks, months that this thing's been sitting in your garage or in a junkyard, but don't assume anything. So we'll test it. And a capacitor, in my mind, is like a battery on steroids. It can hold a lot of energy and build it up and deplete it, offer it to you really quickly. Okay, so whereas a battery, I think of it as a hard drive in a computer in the old days, a spinning hard drive, which is big and slow. Then the capacitor is like RAM, random access memory, which is fast, right? All right, so we're going to remove these two bolts. They might be M6s or something like that. I cheated a little bit and I used the ratchet to loosen them up. So don't give me credit for Hulk-like strength here. I don't want to talk a big game about safety and sockets not falling off and then reach for a socket and a ratchet to loosen these. So I did it off camera. And yes, I'm a hypocrite. Do as I say, not as I do. Just before I forget, you can remove this appendage, the battery connector slash air conditioning connector. You undo these screws, then you undo a couple more on the inside. This thing completely comes off. And just as this is offered as a 3D printed housing, there is a plate, a block off plate, 3D printed for you as well. And by the way, you don't have to buy this from me. You can go online at Open Inverter and get the files and print this yourself if you have a 3D printer and if you're savvy enough and can do it. Okay, so I just want to mention that. That's the beauty of the EV community. A lot of things are offered up in an open type fashion, right? Open source. Okay, so, am I going to get lucky? Or maybe this does come off. Okay, all right, so this just came off this metal plate. I might bring you in here closer so you can actually see what's happening. But there is this plastic. I remember that something was stuck on there, and it's this plastic cover that we're going to use a heat gun, and we're going to apply some heat to it. And then I like to use like a putty that you would use when you paint or fill in holes in your walls before painting. So we're going to use that to get this plastic off. I'll be right back. Okay, so we have our DeWalter White heat gun. That's a very good heat gun, by the way. I have a metric piece of 2x4 that I'm just going to put up here so you guys can see maybe more better. And how can we do this? Maybe I lied. Maybe I need to do something like this. I'm not usually this awkward when I'm doing this. I'm just trying to demonstrate so you guys can see it. And then here's that putty knife. Key to applying heat to anything, you're fine as long as you're always moving. So you're just a shark. You got to keep swimming. Don't hold it, no matter what you're doing with heat. Never hold it in one place and you're going to be all right. As I set it down and I'm about to hold it in one place. I've done this before, obviously, and it just takes time. Being a little bit impatient here. Once it goes, it goes. Try it from the other side, maybe. Trust me when I tell you I've done it before. Hold on a second. I think I have two of these, and this one is flimsy. Yep, had to go for the big guns. This one is a little bit more hefty. All right, we might get a money shot here. All right, job done. This is probably hot as that maybe as well. Let me set this down. Okay, so at this point, this could be potentially dangerous because that could have, current voltage on those two bolts, right? So what we want to do is we want to get ourselves a multimeter, and then we put it on volts DC. However, of course, my connection came out here. However, let me show you what not to do, and this is per Damian McGuire's safety advice here. We don't want to use two hands and ever touch any high voltage, right? Because that could be dangerous. So I wish I had one of these that had alligator clips on it. I don't. So what I'm going to do is I'm going to just take a little extension here, and now using one hand, I'm going to connect to one side like this. And then now I can just use one hand and touch the other one. Okay? And okay, this is super awkward. So there's nothing on there, right? So we are good to go. So this is a little tip, again, so you're not touching it with both hands type of thing. Okay, so we checked it for voltage. Don't have any on there. That's great. Got some battery cables here, and if you need some high voltage cables, you can get them off of obviously electric vehicles in the junkyard or hybrids. But the nice thing about pulling the battery cables is they're wedged underneath the car inside of a big plastic housing which keeps them safe and clean, especially. And so that's a good source for cables. And they're long. Anyway, I'm gonna spare you the agony of watching me put these lugs on this wire and then running the heat shrink on it. So I did this off camera. One thing I will share with you is that I got this hydraulic crimper off of Amazon. And although I don't recommend it because I love the fact that it's hydraulic, I wish we could stick this in a vise and hold it because you really need 3 hands to operate this thing. But what's bad about it are these silly dies. They have some random numbers on them that don't correspond to anything. But more importantly, they tend to pinch and leave sharp edges on the lugs. So I've done this a while, so I kind of know how much pressure to put on to prevent that from happening. But I'm showing you just an idea of what I use, but I don't recommend this unit. So try to find something more better. All right, so now you might understand why we need these about inch, and I don't know what these are, 1.5 inches, 1.25 stand up. So okay, I'm going to remove those 2 screws. Okay, and one of these, this is DC, direct current. It's coming from the battery here. So we're going to mark these, okay? But this is recessed inside of this box, and our cables won't be able to reach in there and connect, right? So this is why I'm demonstrating with a positive, negative grabbing a positive. This is a mess. Okay, so this is what we are after. Okay, we're just making them stand out more, and that's going to go in there. Okay, don't be too proud to label. So that's a positive. And then, of course, using Sharpies, that's our negative. Trust me, you're going to be hanging upside down and sideways on your car, and you want to make this as easy on yourself as possible. So here I'm going to put them on here without the housing. And you can do this for bench testing. We're going to turn around and add the housing to it. This is just to kind of show you the situation here. Okay. Let's see if I can move this sideways so you guys can get a better look at it. How much it pops out. Maybe this way, of course. You guys can see. Yeah, it sticks out a bit. You can use these for on your workbench if you think they're too flimsy. I've ran them in my truck for about 3 years, 3,000 miles, no issues. When you look inside of this inverter, there are some weaker points than these aluminum standoffs, right? So they've worked fine for me. Okay, let's keep going and put our housing on. So this is really nice. James did an awesome job. Let's take these off. Let's see if I can do this. So what I recommend is you kind of hang this off the edge so that the cables can go straight down. It makes it easier. Again, no battery connected. We tested the voltage on it. This is safe to work on. I would say, and see if you agree, I would say that maybe 80% of EV conversion is completely safe. It only gets dangerous when you get to that last final 20%. Okay, so what I like to do here is I'll feed it through, and then bolt goes in, and then the doodad, this type of deal. And of course, doing the first one is easier than the second. And another top tip, and I learned this on my truck with these inverters, is maybe make this connection on the workbench and then carefully install the inverter in your car with this already done, because you don't want to strip those threads on the inside, and you'll just carry these long cables, and then you'll connect them on the battery end finally, rather than connecting them here as the last stop. I find that easier. Leave this loose so you can do the negative side. So here we go. Oh, of course. Did you guys not catch it? Okay. The other sides aren't connected, so I can slip these on. But this is kind of like the fittings on your brake lines, right? You always forget to put it on there after you do the perfect flare, right? Tell me I'm not the only one. Just get that started so it doesn't fall off. And then it's the same deal here. Screw. Yeah, it kind of gets funky on the second one, but it can be done. And of course, I'm standing to the side so you guys can see. You guys probably can't even see, but you get the idea. Okay, got that through there. A little bit monkeying around. Just kind of everything hand tight till it's all kind of in position, okay? And we will reuse the screws here. I think James points out that you want to put some washers or spacers behind there on both of these ends because there's a bit of a cutout. I don't think I bother. Oh, come on. And I didn't clean it up, right? So I'm not gonna go too tight on these because I didn't clean up that surface. Of course you would do that. So I'm just kind of doing this just snug, not fully committed. Okay. Now from the other end, I got lucky on this one. I can just slip on that threaded piece. There's a little rubber piece that goes in there first. That fell out, of course. That goes in there. And you get the idea, right? This stuff is like building with Legos. This is so much fun right here. Okay, I don't think I need to fully tighten it. You get the idea. And then this will nicely snap in there. And Robert's your mother's brother. So there we have it. That's our high voltage connection. Okay, next we're going to do the main low voltage harness. And now we must have words about the main wiring harness. So what's in the box? Okay, so first let me tell you what the main harness is comprised of. Obviously, we have the zombie header. This on one end connects to the zombie inverter, and on the other end, it connects to the inverter. Okay. This plug here is OEM. So let me unwind it here. This wiring harness is made out of Nissan Altima parts, and I think it's a mixture of some Lexus as well. So I can tell because of these gray resolver cables. These are about 6 feet long, and the ones on the Lexus are about 9 feet long, way too long if you ask me, and those are black. Okay, so let me just unwind this. We can kind of start making sense of it. All but 2 connectors are completely unique. So I don't really label the connectors because anybody can figure out where they plug in, except for the 2 resolver cables. For some reason, Toyota, Lexus, call them what you will, made these 2 resolver plugs identical. So you can mix up MG1 and MG2. So these are labeled. Now, if you buy a pinned harness like this, then the individual wires won't be really labeled. Sometimes they are, but they probably won't be. Anything that's loose and not pinned is always labeled. So sometimes if you want to save money, you'll get it without me pinning it to the header. In that case, every wire will be labeled so you know exactly where to pin it into that header, right? So we have the VCU connector, we have the inverter plug, we have the MG1, MG2 plugs. By the way, I might start calling MG1 generator and MG2 motor. That's what Toyota calls it in their wiring schematics. So just throwing that out there. In addition to that, we have what I call the safety neutral switch. It's really the gear position sensor or switch. This just sends feedback from the transmission to the zombie what gear it thinks the transmission is in. It doesn't shift the transmission, it just picks up the signals. So we want to know when in park, we want to know when in drive, and we want to know when in reverse, basically. So you get that plug. Then I'm calling this one optional, but this other one also goes to the transmission, and this one is for the ECT shift solenoid or solenoids. And this is what would electronically and automagically shift the transmission between two gears because we have a low gear and a high gear. I'm calling this one optional. You can drive your car without this connected and it just stays in the default gear. I've been driving my truck like that forever. I always get confused which gear it's in. I think it's in high gear by default. Okay, then this next thing is important. This is the throttle harness. This particular one is wired for the BMW throttle pedal. Okay, I will ask you what throttle pedal you plan on using or which one you already own. If you don't have a throttle pedal, you can tell me which one you want, and most of the time I have them in stock, and I'll sell you a pedal. You don't have to buy a throttle pedal from me. You can just tell me which pigtail or harness you want, be it a Prius, a Lexus, a Camry, an Altima, and I will wire it correctly for you. So all you have to do is just plug in your throttle and calibrate it. So this is a throttle. Then what we have in here is two CAN wires. So I give you a CAN 1, we can call it. I think in the code it's referred to as CAN 0, but we called it, let's call it the first CAN. So for CAN, controller area network operations. So I give you CAN 1 and I give you CAN 2. Just so you know, you can have multiple CAN devices just daisy chained on one CAN. So if you have a CAN controlled, let's say, onboard charger, and you also have a CAN controlled DC-DC converter that happens to be a separate box, separate unit, that's fine. As long as they run on the same CAN speed, they can be on the same wire, if you will, right? But sometimes you might have something like, I don't know, maybe some funky floor shifter that runs on a different speed of CAN. So then you can put that floor shifter on CAN 2 and then have your charger on CAN 1. You can have your BMW safety box on CAN 1, that type of stuff, okay? And then what else do we have here? And then we have the 4 wires that are loose, essentially, and these are the power to the zombie. And so we have a black wire, which is, and these are all labeled, by the way. The black wire is ground for the actual zombie verter, and the red wire is permanent power for the zombie verter. Okay, the zombie verter always needs permanent power. It helps it with scheduled tasks, that type of thing. All right. I'm going to unwind these. I forget how long these wires are. I think they're pretty long, maybe 3 meters. So I give you plenty of wire. I will include extra pins for this connector. I also throw in some extra wires that are already pinned. All you have to do is just plug them into the back of this connector. You do have to remove these yellow pieces here, yellowish orange, in order to push the pins in, but there's obviously room for expansion. I think right now I'm pinning about 33 pins out of the 56 on here. I plan on expanding that to just over 40 once I'm fully done implementing everything I want to implement. And by that, what I mean is that the zombie can control a contactor box. That's where I'm headed, is that I want to provide that. Just because I'm not doing it now doesn't mean you can't use it to control your own, your DIY contactor box. You just plug in those 4 wires or however many into the back of that header yourself, right? And those might be what you use the loose ones for. But I'm not pinning them yet because I haven't built a DIY contactor box that I want to include with these harnesses. One other thing to be said, I've only been at this for less than a year. So right now what I'm selling are technically wire harnesses, okay? Sometimes I misspeak and I call them wire harness kits, but they're not really kits, because when I think of a kit, I want it to be a complete turnkey solution, and I'm already working on this. Hopefully I'll have them out this year, and those will come in 2 flavors, but it'll literally be a turnkey where all you have to do is just connect the positive wire to your battery, the negative wire to your battery or the chassis of your car, and this kit will come with a fuse / relay box, all the fuses in there, all the relays in there, and even the wires that would go to your ignition key for classic cars. So it would be off, on, start type of setup on that one. And then the other one would be a little bit more modern, where it will just come with a start button. But again, both of those kits that I hope will be available later this year will come with a fuse box and a relay box, all in one type of thing. Not too big, very basic. Maybe 2 or 3 relays in there, maybe 6 fuses, but with possibly an expansion for you to add more and build up on it. Okay, so here's the harness. And what can we do with it? What's the first thing I would do with it if I received this? In this particular case, the customer sent the zombie circuit board to me. I soldered on the header. I installed it in the enclosure here, and I'm shipping it to him with it. But you may already have your own zombie. You may have the enclosure. You just tell me what you have and what I don't need to include in the kit, and we work together to get you what you need. But basically, to start, you're going to have your zombie inverter and you're going to have the harness. And the first thing I like to do is just power this up, essentially using the harness. We could just connect 2 wires to 2 pins on here, pin 55 and pin 56. But because we have a header, we're just going to connect this header to the zombie, and we're going to pull out 2 wires from this entire thing, a black one for ground and a red one for permanent power. And they are labeled. And those will connect either to a car battery or to a bench power supply. What are you guys in the mood for today? I think today I'm going to bust out a bench power supply. All right, so we don't need anything else. Okay, so what am I trying to do here? Okay, so this has this little slider. This is a really nice plug. This is a really nice header, great enclosure, obviously brilliant circuit board and Wi-Fi card. There's only one caveat to this plug, and that is that although the outside of it is made out of hard plastic, the little clips that hold each pin in, they kind of grab the pin from top and bottom. You have to spread both of them out to pull the pin out, okay? These plastic retainers are soft plastic, so I don't recommend unpinning this. Avoid trying to unpin any of these wires if you don't have to. And if you want to change something, maybe cut the wire and splice a new wire into it, but leave it pinned. I bought one of these from AliExpress with that long, what I call horse's tail, and it showed that it comes with like 8 different colors, let's say, right? But the colors all came in batches. So it was like 8 white, 8 yellow, 8 red, 8 black, and it drove me bananas. And I just wanted to reshuffle them. And I even went out and bought the proper tool for unpinning this, which is completely useless. It's very expensive, but useless. And I damaged one plug just trying to carefully and cautiously unpin all 56 wires. It was a nightmare. So avoid that if you can. That's your top tip. Okay, so we're gonna connect this header. Oh, by the way, I've said in my prior videos, we take the lid off so that we can see one solid LED light up on here and another one next to it start flickering. Okay, so let's see if I can do this correctly. So put it in there, press that down, I think. Okay, so although all the wires are connected to the zombie, like I said earlier, we're only interested in 2, okay? So there's our zombie. Oh, look at this. And then these ends will go to bench power supply. I think I'm gonna bring you guys in closer so you can actually start seeing what is happening. So I have my cheapo Amazon bench power supply here, and first thing we want to do is just do the power up test to make sure that our zombie powers on. And we could just take the alligator leads with these clips and clip them on to these wires, the red one for positive, the black one for negative, assuming of course that we preset this for 13 volts. But as my old supervisor used to say, we want to do same or better. So let's see if we can do better than this. So instead of using these leads, let's remove these. Okay, instead of those leads, what we're going to do, these unscrew by the way. We're going to add some leads on here. Regular wire with ring terminals. This is what I like about this setup. That's our ground or negative. We're going to do the same thing on this side, but the positive one is going to have an inline fuse. This is like 7.5 amps on this fuse. We're going to add this guy here. And let's just confirm that this is preset for about 12, 13 volts. Let's see. Yeah, it's close enough. So turn it off. And now we're back to using these guys for the quick connects and disconnects. I really like this. So the negative one is really easy. And yes, this is kind of silly for now because it's just 1-to-1, but we'll build up on this. Okay, so there's our ground. Again, we just need 2 wires. For the positive side, I like to use inline fuses like this. This is one of those glass fuses. And the nice thing about it is that if it's in line, then I know which fuse blew and which is affected. So it's easy to troubleshoot. And again, this is kind of not making sense if it's just a single 1-to-1 relationship, but you'll see how that builds up. So then we take the other end and then we connect it to here. And now, so we have our 2 leads. We should be watching for some LEDs either lighting up or flashing. And this is our first test. This is essentially the extent of it. There is nothing else connected. There is no inverter. There's no transmission. There's no throttle pedal. It's just us powering up the zombie just to see if it will power up. Okay? Next, we'll bring out a laptop and we'll see if we can connect to the Wi-Fi interface. Okay, so we go to our networks And this one is called Zombie Verter. Yours may be called something else, but it's whatever new one pops on here. So we want to connect. There is a way to hide all these networks so you don't have to see them. I've done that before for making videos, and then they just freaking come back, or if you don't explicitly hide them, the new ones just keep popping up and showing up. Okay, so it's connected. It says no internet. That's totally fine. Now, I'm a computer nerd, so I live by the motto of trust but verify. So I'm going to go to a command line. This is totally optional. And if you do ipconfig, then this shows you that you got an address of 192.168.4.2. And I think that thing runs on 192.168.4.1. You do have to get to it by IP, unfortunately. Okay. We are on the web page. So the web page comes up. This is great. What I'm going to do here is I'm going to disable this auto reload. That's a handy feature, but not if you're going to be configuring. We're going to go to parameters, pronounced settings. Okay, so we want to check that the inverter, notice the inverter is not hooked up, transmission's not hooked up. It doesn't matter. You can still play with this interface. You can configure it. So the inverter is, GS450H, the vehicle BMW 39. I think I'm just going to change that to classic. Transmission, we'll leave it on auto. And I think that's pretty goodish for now. I think what we can do next, and this is what's interesting again, is that at this point, we took another step. We went from just checking if the VCU will power on. Now we check to make sure we can get to the web page. That is good. We can say save parameters to flash. And then now we're in parameters or settings. We told it we want to have the Lexus GS450H inverter. The next thing we can do before hooking up the inverter is we can just hook up the throttle and we can bench calibrate it. I say bench calibrate is because you want to do it on the bench for testing, but then always recalibrate your throttle pedal once it's installed in the vehicle. And that is because once installed in the vehicle, the range of motion may be limited, the amount of sweep that you have. So recalibrate it once it's in the car. Okay, so I'm going to go get the BMW pedal that goes with this harness, and I will be right back to calibrate it. And here is our BMW E46 throttle pedal, or as the cool kids call it, 3 Series. Sorry, I don't speak BMW. So we are just going to connect it. Simply plugs right in. Okay, I think we are back in business. I'm going to refresh this page. Since we reconnected, it put us back at the dashboard. We want to turn off for a second auto reload. Okay, we're going to parameters. And under parameters, which are settings, we want to get down to throttle pedal because we want to calibrate this thing. So here we have, this is a 2-channel throttle pedal. So pot min, pot max is channel 1, pot 2 min, pot 2 max is channel 2. And so we want to set these values. So parameters where you make the settings, spot values, that would be like our feedback. So let's see what this zombie verter sees as far as signal on pot and pot 2, I should say. Okay, so right now, let's reload this just to be sure. We calibrate the throttle in 2 positions. The first one is you don't touch the throttle, it's off essentially. And we want to get the values for when we're not pressing it. Just to show you, prove a point. Where are they? So here you can see there's 436 is for pot, channel 1. Well, when I press this, that value changed, right? So we want a 438 and 222. So those would be like the minimum value. So we want to add about 10 or 20 to those. I'm going to call it 450 and 250 just so I can remember those. So okay, let's just say save parameters here. Now we want to do it with the throttle fully pressed down. So like this BMW throttle pedal is, I just noticed, is unique because it's going to be calibrated the same way in the car. I don't think anything will obstruct it because it's a unique one that it's floor mounted. So when you press it down, it bottoms out on itself. But I'm telling you, with some of the other pedal designs, that is not the case. Okay, so now let's go to spot values. And again to pot, so channel 1, channel 2 is here. And this time we want to do auto reload. And press it down. And it's 2400 and 1200. Okay, turn it off. So for the max, you subtract and then save parameters. Okay, so now we just accomplished another milestone. We just calibrated the throttle, which is great. Next, we can prepare ourselves for actually connecting the inverter. Okay, so there are, I think, a couple settings in here that we need to take care of in order for us to bench test the transmission. Our goal is to get the transmission to spin, right? So DIR mode, I want to set to default forward. Yes, we have a shifter, sensor, and harness for it, but we're going to do this very basically and simple. So default forward means regardless what gear we're in, as long as we're not in park, we're ready to drive. So save settings on that. And then UDC min, we want to set that to, let's say 0. That's the voltage that the inverter needs to see in order to be ready to go. You would normally in the car have that higher, like 300 volts, but for bench testing, I'm going to use a battery module that's only 48 volts, so it will never see 300. There's one more. UDCSW, this is what voltage we need to see in order to close the main contactor. This also on the bench test needs to be set to 0. Before shipping this to a customer, I'm going to change these to default just so that if he hooks it up to his car and doesn't bench test, it doesn't blow things up. Okay, those two settings may be it, and we should be able to connect the inverter up next and it should power up. So let's do that. Let's save these settings. Okay, so now we're adding an inverter. So let me show you how I test what I do when I'm adding an inverter. There's actually two things that you can do. So first of all, we need to obviously make our connection here. So we're going to use the OEM inverter plug on this socket. That should just snap right in. It's quite unique that for redundancy and safety, I'm sure this inverter uses 2 ground wires for redundancy and then 2 essentially 12-volt wires. So those are blue and white. The grounds are black. So now, first thing what I like to do is just power up the inverter by itself without the VCU even being on. And what I'm trying to see there is if it's going to draw any power from our bench power supply. So what I'm going to do here is I'm going to replace this 1-to-1 gray doodad with a 3-way, because now we're adding 2 more grounds. So hopefully this nonsense is starting to make sense. So now off of our main ground coming off of the power supply, we have 3. So we can put our ground for the VCU back on, although we're not going to be turning on the VCU. And then now here we're adding the 2 grounds from the inverter. So here's 1, and then here's 2. And these come labeled. Okay, so our grounds are connected, okay? Just get them out of the way. And then we are going to do something similar on this end with the power, the 12 volts positive. We're going to disconnect the VCU temporarily. And here is a lead for the inverter. It has an inline fuse. I'm just going to keep this 1-to-1. We're eliminating the VCU for now. So that's, and then it has this 1-to-2 splitter thing, because again, there's 2 leads coming off of the inverter. So we could twist them together, but I just like to keep them separate like this. Okay, so it goes, the 2 leads from the inverter go to a 1 wire with a fuse on it, and then it continues on to our master fuse right here. Hopefully that makes sense. Okay, we cross our fingers and we power it on, and we're hoping to see some sort of a draw. I'm going to walk around this counter. Okay, so it is drawing 2 amps. So it's doing something. Unfortunately, there are no LEDs, no flashing lights, no noises, nothing when this thing is powered on like this. Later, when we add the high voltage leads on here on the business end, then it will start humming or hissing, if you will. But for now, you can't hear anything. So to really confirm that it's on, we want to hook up our VCU now. So let's do that. Got to replace this one with a 2-way. 1 second. Obviously, when I'm not doing a video, I'm more efficient than this. I'm kind of flying through these steps, but since I'm trying to demonstrate, I'm trying to go slower and keep switching these things. Okay. So, disclaimer. This isn't how things get powered on in the vehicle, okay? I'm doing a test here on a workbench, and sometimes you have to kind of divide and conquer. Sometimes you may be doing things out of order. Sometimes the order on a workbench really doesn't matter, okay? But if this was in the car, the inverter will be powered on via a relay controlled by the zombie, okay? Some of these things are up to you. In my truck, I don't power on my inverter via a relay controlled by the VCU. I do it with the ignition switch, so it's a manual control. Now, before we attempt to turn on the inverter, to see if the VCU can actually see its status as on, we need to introduce another control wire. And this is one of the 4 wires that give power to the VCU. So we have the black one, which is ground. We have the red one, which is permanent power. And we are adding an orange one here, which is ignition on. And we are expanding our little junction block we went, I think, from 1 to 2, and now we're going to 4 total wires. So I'm going to add this to our main lead. And then what is happening here is we're adding our VCU permanent power back in. Okay, so we turn on our VCU back on. Before I connect anything else, let me start recording the session here. And we want to bring up the web interface. And we are going to go into spot values. And we're looking at T15 stat and inverter stat. So once again, we are introducing another control wire. It's the orange wire for ignition on. And I'm going to be adding an inline fuse for it, like so. And now when we look at our web interface, T15 stat or ignition is on. So now we will power up the inverter. And voila, now our inverter says on as well. So yet another milestone. Okay, next we are going to connect the high voltage to our inverter and actually see if we can spin that motor. So first thing we're going to do is we're going to reconnect high voltage battery module here to our inverter. Let's see how we can do this. I like for it to sort of hang off of the edge here, makes it easier to connect. I do have these quick disconnects on here. So one, the positive lead is fused and this is off. And I have another one disconnect on the negative lead. Sort of the belt and suspenders approach. For bench testing, I'm not using that orange safety housing. It's just easier to connect, and we're dealing with lower voltage, lower amperage here. Once again, doing things left-handed. Okay. And I'm just going to get my resolver cable leads ready here. Okay, so that's our resolvers. See if this will reach. I think just for demonstration purposes, I'm only going to connect MG2 here so that you can easily see the 3 phases right there. And then let's get our resolver cables. And I do label these. So this is MG1. Let's get this guy out of the way. So MG1 goes in the front, clicks on there, and then MG2, hopefully you guys can see this, goes right behind it. This is where the low speed, high speed shift solenoid control would connect. We don't need it for a simple bench test. And on the other side is where the safety neutral switch would connect. Well, those are hanging down there. We don't need them for a quick test. Remember, our direction is set to auto forward or always forward. So this should be good enough. Okay, time has come for the final phase, final step here, and that is to actually spin this transmission. So we are introducing our fourth and final control wire. This is the yellow wire, and this is the start. It's momentary press. This is going to be just a start. Once again, I am adding my little individual fuse here for that particular lead. So let me add it in here. So now we have our red wire, which is our permanent power. We have our ignition, which is our orange. Need to regroup here. So that's ready to go. And we have our, then we actually have our inverter. Let me unwind this. Thought I was all ready to go. Then we have our inverter, and then we have our momentary start. Momentary press, okay? All right, so let's walk through this. So I have a screen recording going here. Our permanent power is already connected. What we're going to do is go down to a section where we can see the status of our ignition. We can see the status of our inverter. Ignition status is off and inverter status is off. So we are going to turn on the ignition, T15 stat, turn to on. Now I'm going to go turn on my high voltage. I'm doing this manually, of course. So here's my positive lead on, and here's my negative lead on. Okay, now I'm going to turn on my inverter. And inverter status has changed to on. This is really good. Now we scroll up to the top so that we can see a new parameter called op mode, operational mode. It's off. So this is our last control wire. That yellow wire comes in. It's a momentary press. So we hit that, and our operational mode has turned to run. We can check one other thing real quick. We can go down to where it says dir for direction, and it's set to drive. If we were shifting our gears, then this would be in park, and we have to shift out of it to either reverse or drive. But because we are set for default forward, that is set to drive. So here we go. I don't want to gun it too much because of the regen situation, but success. So I hope you guys stuck around till the end of the video. I know it's been a long one. Thanks so much for watching.